I'm going to be talking to you today about literal equations and dimensional analysis. Some equations contain more than one variable. The processes for solving one-step or multi-step equations are used to solve these equations for one variable in terms of the other variable. A formula or equation with multiple variables is called a literal equation. Many formulas require using dimensional analysis, the process of carrying units of measure throughout a computation. Many real-world problems require the use of formulas, especially in science. Solving a formula for a specific variable may help to solve the problem. And then I have the most important thing is to solve the variable for the problem tells you to and get that variable by itself or isolate the variable. Number 1 says solve 5b plus 12c equals 9 and solve it for the variable b. So I'm going to try to get this b right here by itself, isolate it. So how do I do that? What is farther from the b, the 5 or the 12c? The 12c. So since I'm adding the 12c, I'm going to subtract 12c from both sides. So it would cancel out on this side. Now on the right side, we know that I really can't subtract 9 minus 12c because they're not like terms. So I'm just going to list it next to each other like that. Okay. So now all I have is 5b equals 9 minus 12c. The only other thing that I have to do is divide 5 by both sides because the 5 and the b are being multiplied. It would cancel out and I would get b equals 9 minus 12c over 5. And that is perfectly fine. Another way that you could write it if you want to, you could go 9 over 5 minus 12c over 5. Now, usually the only time, I prefer this way, the only time that you see this generally is when one of those fractions can be simplified. Number 2 says solve 7x minus 2z equals 4 minus xy for x. Now you'll notice that we have two x's in this problem. So what you're going to want to try to do is you're going to want to try to get everything with an x on one side and everything without an x on the other side. So I'm going to put all my x's on the left. So what I'm going to do is I'm going to add that xy to both sides. What happens is I'm left with 7x plus xy minus 2z equals 4. Now, you'll notice, of course, that this 2z does not have an x in it. So what I need to do is move that to the right side of the equation. So since it's subtracting, I'm going to add 2z to both sides of the equation. When I do, I'm left with 7x plus xy equals 4 plus 2z. Now, everything with an x is on the left. What you need to do is to do the opposite of the distributive property and factor out an x. So what would be left? What's the opposite of the distributive property? Well, that x is being multiplied by the 7, so it is there too. Right here, the x is being multiplied to the y, so if I wrote it like this, it's still being multiplied to that y. It's just the opposite of the distributive property. And I would have still the 4 plus 2z on this side. Now, the reason that I need to do that to factor out this x is because now we can see that this x is being multiplied by everything here. So what I have to do to isolate that x is divide everything. When you do, all of this will cancel out and you'll just be left with x equals 4 plus 2z over 7 plus y. And now we have isolated that x. If you need help with this, please see me and pause the video and write it down. Number 3 says a car's fuel economy, E, in miles per gallon is given by the formula E equals M over G, where M is the number of miles driven and G is the number of gallons of fuel used. Solve the formula for M. So I'm going to write it first. I'm going to say E equals miles over gallons. So all they want me to do is to solve the formula for M. So I'm going to isolate that. How I do that, if I'm dividing by G, the opposite would be to multiply by G. So I get miles equals the fuel economy times gallons. That's all you have to do for A. B says if Haley's car has an average fuel consumption of 30 miles per gallon, so this is fuel consumption, miles per gallon, that's the economy, and she used 9.5 gallons. How far did she drive? Okay, so this is gallons, and how far did she drive in miles? Okay, so I'm going to say miles equals E times G from part A, and I've got miles equals the economy it's saying is 10, and she used 9.5, so I'm going to say times 9.5 gallons. And if I work that out, I would get 285. So I would like you to say she drove 285 miles. And that would be your answer. In number 4, we're going to be using dimensional analysis to convert between units of measure. So number 4 says the average weight of the chimpanzees at a zoo is 52 kilograms. If 1 gram equals 0.0353 ounces, use dimensional analysis to find the average weight of the chimpanzees in pound. And I have hint 1 pound equals 16 ounces. So I'm going to show you how to do this. And mainly you're going to be using this in science, but I can tell you most science teachers want you to set up dimensional analysis problems like this so that you can cancel out the units. All right, so we're going to start on the left with 52 kilograms. Now, so that's our starting point. We're wanting to get to pounds over here. Okay, so our final result we want to be in pounds. Okay, so 52 kilograms, you have to convert first kilograms to grams. So I'm going to do that. We need to convert to grams. So because I want to convert to grams and I want to cross out the kilograms, I need to put basically whatever unit I want to cross out. So I want to get rid of kilograms. Whatever unit I want to cross out, I need to put it diagonally across from it so it can cross cancel. All right, so there in 1 kilogram, there's 1,000 grams. See, the kilogram is diagonally across from itself. Okay. Next, I'm going to go from grams to ounces. So again, I want to cancel out grams, so it needs to go in the denominator, in the bottom, diagonally across from where it is. So I'm going from grams to ounces. In the problem, it tells you 1 gram is 0.0353 ounces. Now, once you go to ounces, you can go right here from ounces to pounds. So again, I'm going diagonally across. So if ounces is in the numerator, it needs to be in the denominator next. And then I'll have pounds in the top. So in 1 pound, there's 16 ounces. Okay, so this is why I'm fixing to show you why you set it up the way that you set it up. Okay, kilograms will cross out with this kilograms. This gram will cancel out with this gram. This ounce will cross out with this ounce. And the only unit that you will have left is pounds, which is what we want. Okay, So what you're going to do is you're going to multiply every number in the numerator together. So you're going to go 52 times 1,000 times 0.0353 times 1 divided by all the numbers in the denominator. So 1 times 1 times 1 times 16. So I'm going to say 52 times 1,000 is 52,000 times 0.0353 times 1, and I get 1,835.6. And then I'm going to divide that. 1 times 1 times 1 times 16 is 16. If I divide that, I get 114.725. And then the question is, again, use dimensional analysis to find the average weight of chimpanzees in pounds. So I could say chimpanzees weigh about 114.7 pounds. That would be perfect.